All right, folks, now we're looking... All right, folks, now we're looking at the multiplicity of zeros. Now, what I mean by that is, see this equation here? That has 3 zeros, yeah? The zeros are 0, 2, and negative 2. Multiplicity of zeros, I mean, we could have had x outside of x plus 2 squared times x take 3 to the 3. The multiplicity is what it's raised to. But before we kind of discuss that in further detail, I'd like to remind you of things. If I had y equals x to the 1, which is just y equals x, that would look like this. Hang on. It would look like this, straight line. If I had y equaled x squared, then that would look like this. And you should definitely know this. Okay, just pretend I could draw. Oh, why can I not draw? That would look like that, yeah? And if I had y equals x cubed, then that would look like, it's this weird one. It looks like that. And if I had y equals minus x to the 1, then that's the same, but it's going downwards. Like that. If I had y equals x minus x squared, then that's like that, but this time it's downwards. And if I had y equals minus x cubed, you can probably guess what it's going to look like. Instead of going up like that one, it's going to come down like that one. I just can't draw. Okay, there's a reason I got into that. It's because at each root, when you sketch it, it starts to look like the thing its multiplicity represents. That's really confusing, I know. The best way to understand this is to do a few. So, for example, if I had p of x equals x take 1 squared x take 2. Now this one is squared. Oh, my watch didn't like that. And this one's to the 1. Then the zeros are, well, x take 1, so that's positive 1, and that's multiplicity 2. And we've got positive 2, and that's multiplicity 1. Which is what we also call as simple 0. Which means here it's going to look like a quadratic. It's going to look like x squared. And here it's just going to look like a straight line. Look like x, straight line. So if we go to sketch this, I'll do my axes using a ruler. Y and x. And I've got zeros at 1 and 2. Then that's either, well, at x equals positive 1, it's multiplicity 2. So it cuts back on itself. So right up close, it looks like a parabola. And then it's going to come down and go like that. Or I could have had it going up and looking like that. The only way to tell is to figure out its behaviour at one of the extremes. So behavior as x tends to negative infinity. So I'm going to chuck in x equals, literally anything than the least 0, so anything less than 1, so 0. P of x equals 0 take 1 squared, 0 take 2, which is going to come out as a negative. So it's going to be not this one. It's going to be that one. It's going to look like that. So here, that looks like a quadratic because it bounced back on itself. And here it looks like a straight line. If you zoom in. We'll do another example just to kind of show it a bit more. So if we were to sketch P of x equals minus 2, x take 2 squared, x plus 1 to the 3, x take 1, then that's going to look like, well, our zeros. We've got positive 2, and that's multiplicity 2. Multiplicity 2. We've got negative 1, and that's multiplicity 3. And we've got positive 1, and that's multiplicity 1. Yes. And its behavior as x tends to negative infinity. So let's sub in x equals, it's got to be less than at least 0, so I could go anything less than negative 1, so negative 2 will do. P of negative 2 equals negative 2. Well, that's coincidental. Maybe I'll change this to negative 3 so it's more obvious. Negative 3. P of negative 3 equals negative 2 outside of negative 3, take 2 squared. Negative 3 plus 1 cubed, negative 3, take 1. So we've got negative 2 times, negative 3 take 2 is 5 squared, positive 25, times negative 3 plus 1, negative 2, and cubed, negative 8, times negative 3 take 1, negative 4. So that's going to give us a negative. It's always good to know the y-intercept. X equals 0, so P of 0 equals negative 2, 0 take 2 squared, 0 plus 1 cubed, 0 take 1, which gives us negative 2 times 4 times 1 times negative 1, gives us positive 8. So now let's sketch. So I've got zeros at positive 2, negative 1, and positive 1, and a y-intercept at positive 8. 1, 2, 3, 4, 5, 6, 7. Oh. I'm just going to make this 8. Negative 1, positive 2. And I know that because this is negative, I'm going to be starting down here. Now, as it goes through negative 1, that's multiplicity 3. So it's not just going to cut through, and it's not going to bounce back. What it's going to do is it's going to do a weird little, what we call a horizontal inflection. Then it's got to at least go up to the 8. Oh, no, I shouldn't have made that a straight line. It's got to at least go up to the 8. These never look good, by the way. And we know its thing at positive 1 is multiplicity 3, so it's going to look like a straight line there. And then at positive 2, it's multiplicity 2, so it's going to bounce back on itself. That just tried to get in the window. That's weird. So that's kind of what it's going to look like. Again, these never look good.